Here we have 6 basic functions to graph. So remember, we're working with coordinates. Right, let's draw the, oops. We have x-axis. We have y-axis. So for A, go back to pencil. For A, we call identity function. Right, let's see, this is the y-axis. Right. This is the x-axis. But we are in the function world, so our notation is f of x equals yx. But every point on the plane has x value and has a y value. But in the function world, every point has a value of every point. The first one, the first member is x. The second member, instead of seeing x or seeing y, we see f of x. But this f of x is just the old y, right? It's the old y we know. We call this function value, right? So it's in a function notation. So the first, so A is y equals to x. So where is a graph of y equals to x? It cuts the graph into half, right? So let me draw here. Change the color to be red. So it cuts the first quadrant into half. It cuts the third quadrant into half. So basically the straight line goes through the first quadrant and the third quadrant. So this line is it's f of x equals to x. We call identity function. Identity function. So every point, the function value equals to the input value. So x value, so this is x, and this is f of x, they equal to each other. So this is x value, and this is f of x, the older y value, right? So that's why it gets a name, identity function. Because every point, the x value and the y value are the same. So this is a graph of A. Now let's see B, let's erase this. Let's grab the line again. X-axis and the y-axis. Now let's change our color to be blue. So B is called the absolute value function. Absolute value function. And because of the absolute value sign, it changes every negative to be positive. So we have, so our graph looks like this. It's like a V shape. Right? Every x value equals a y value. And every negative x equals a positive x value because of absolute value sign. Let's just mark one. Let's see if this is a positive x, right? The function value equals to f of x. If it's a negative x, the function value equals to absolute value of x. Okay, that's a B, absolute value function. It's a V shape. Now let's see C. C is a polynomial of degree 2 or quadratic function. And it's an even function because f of negative x is negative x squared, which turns out to be positive x squared. So our graph is a wiggly line. Let me use red color. Oops, not straight. Not straight. So how do I change it to be not straight? Okay. It's a smooth. It's a smooth, roundish. And then the left half and the right half are symmetric with the y-axis. Right, so this is x squared. Now this is square root of x. X-axis, y-axis. Now let's use blue color. Square root of x. Think about the domain. The domain for this one is different from A, B, C. Right? If we go back to A, go back to B, go back to C, we see the domain of the function, which means the suitable x value can be all real numbers. But not for this one, not for D. D is under square root sign. It has to be non-negative. Has to be non-negative. So the range can be started with 0, and the domain also can be 0. So our graph goes this way. Something like this, right? The lowest point will be 0, 0, which is the origin, right? But it cannot be negative. X value cannot be negative, and the Y value, the function value, cannot be negative. So this is a graph of D. Graph of E, let's graph another coordinates. Now let's use a red color to graph it. It's a cube, so it's an odd function. It's an odd function. So even function are symmetric with y-axis. Odd function are symmetric with the origin. So one piece we get it from the first quadrant. Looks like this. This keeps going. And the other piece wiggles. So at the 0, 0, at the origin wiggles. Then the other piece is on the third quadrant. And of course, it keeps going down. So this is a graph of x cubed. Cubic root of x looks like square root of x, but its domain, the domain of f is different from domain of D. Domain of D is x has to be negative, which means x has to be greater than or equal to 0. But for f, x can be all real numbers. Right? Going back again to be all real numbers. So the shape looks like square root of x. Let's use blue color to draw. So we have one piece going like this in the first quadrant, and another piece wiggles. Oops, wiggles at the origin. Then the other piece goes this way. So this is the cubic root of x.